Today's lesson is analyzing categorical data. So we're going to be solving problems involving bar graphs and solving problems involving circle graphs. Bar graphs organize data into categories and show the frequency for each category. You identify the frequency for each category by comparing the height of each bar. Bar graphs are used to compare data. So we're going to highlight that because that's important to know when to use bar graphs. In example 1, they give us a bar graph, and the question says, 3 boys and girls ran for 7th grade class president. The boys are Andrew, Derek, and Miguel. The girls are Becky, Dora, and Tricia. The results of the election are shown in the bar graph. Which percent is greater? The percent of total votes for boys that Derek received, or the percent of total votes for girls that Dora received? So that's the question we're trying to answer. Which percent is greater? Was it the percent of total votes for the boys that Derek received, or was it the percent of total votes for the girls that Dora received? Before we start working on answering this question, we are going to look at our bar graph. You should always, always, always notice your title. These are votes for 7th grade president. You should notice your axes labels. So this is your y-axis, which is your dependent variable, and it's titled the number of votes. So these numbers here represent the number of votes, and your x-axis label is these are your candidates. And so we talked about how there's 3 boys and 3 girls, and the height of their bar shows the number of votes that they received. Well, I want you to notice that this little break in our scale is because it jumped from 0 to 75, and all the other intervals are counting by 15. So from 75 to 90, 90 to 105, 105 to 120, they're all 15 away except for that first one, and that's the reason for that little break in our bar graph. You always want to notice all the details in any kind of graph we're doing before you start to go answer questions about it. So now that we've looked at it and we understand what this graph is talking about, now we can start to answer questions. So in step 1, it wants us to calculate the percent of total votes for boys that Derek received. And we're going to set up a ratio to do that. So the number of votes for Derek, if you look at the height of Derek's bar, it's at 135. And we are looking at the total number of votes for the boy candidates. So Andrew is at 75. We're going to have to add 75. We are going to include Derek, so we do have to add back that 135, plus Miguel is at 90, so we're going to add 75 plus 135 plus 90. So Derek got 135 out of the total for the boy candidates was 300. Well, I need a percent, so we're going to set up a proportion to find that percentage. When we talk about proportions, we need to set up this ratio and set it equal to x out of 100, because you know from a previous lesson that a percent is any number out of 100. So to get my x value, I could use the shortcut method. What did I do to 300 to get 100? Well, I divided by 3. So if I go divide 135 by 3, I'm going to get x equals 45. So that means that 45 out of 100, that gives us our percentage. That means that that is the percentage Derek received for the boy candidates. So we want to say Derek received 45% of the votes. And now, in order to compare, now we have to figure out Dora's percentage. So Dora's bar is at 150, and we're going to have to total up all the girl candidates' votes. So Becky is at 105. Dora is at 150. And Trisha is at 120. So when I add 105 plus 150 plus 120, my total is going to be 375. Well, again, I need a percentage, so I'm going to have to set my ratio of 150 out of 375 equal to x out of 100. I can cross multiply here, cross multiply and divide. So remember when we learned how to solve proportions, we cross multiplied and divided. That's what we're going to do here. So 375 times x is 375x. And 150 times 100 would be 15,000. To get x by itself, I'm going to have to divide both sides by 375. And I'm going to go show my work over here. 15,000 divided by 375. So 375 goes into 1,500 4 times. That's 20, 28, 30. That's 12. That worked out exactly. So when we subtract, we get a 0, but notice we still have a 0 to bring down. So 375 goes into 0 times. You need to show that up there. And so our percentage, or x, is going to equal 40%, because 40 out of 100, that is a percent. So Dora received, let's see, I'm going to write this. Let's just say, let's just put Dora received. So she received 40% of the votes. Now, to compare the percentages, we know that 45% is greater than 40%, which means Derek received the greater percentage. On the Your Turn, you're using this same example 1, the same problem with the same bar graph to answer this question. Okay, they want you to calculate the percent of total votes that Dora received. Okay, so this would include not just for the girls, but total votes, boys and girls combined. So pause your video and show all your work, calculate that. All right, so if I go add for total votes, the 300 for the boys and the 375 for the girls, well, that would be 675. So we're going to set up our proportion, Dora over total. Dora was at 150, but our total is now 675. And since I need a percentage, I set it equal to x out of 100. Well, I could use the shortcut instead of doing this cross multiplying and dividing. Really, it's the same thing. I would say, what did I do to 675 to get 100? Well, I could divide by 6.75. So I could go do that to the top number 2, divide by 6.75. And I'm going to show that work over here. So 150 divided by 6.75 would mean that I need to make my outside number a whole number, move it twice to the right. Whatever you do to the outside, you do to the inside. Start at the back, 1, 2, bring it up, add your 2 zeros, and now you can start your division. So 675 goes into 1,500 twice. That's 10, that's 15, 12, that's 1,350. When I go subtract, I am going to have to regroup here. I get 150 and I have to bring down this 0. So again, it's going to go twice. And we already know that's going to be 1,350 again, which is going to again give us that 150. Well, since I already have a decimal there, I could attach a 0 and bring it down. But you'll notice again, I have that 1,500. So what's happening here is this decimal is a repeating decimal. So we're just going to say that it's about 22%. On the next section, we start to solve problems involving circle graphs. Okay, a circle graph shows how a set of data is divided into parts. The entire circle contains 100% of the data. And you know that a circle represents one whole, so that always has to add up to 100%. Each section of the circle represents one part of the entire data set. Data values are often given as percent. So we are always looking at parts of a whole when we're looking at our circle graph. Before we start to answer or even look at the question, let's look at our circle graph. Okay, our title, we're talking about ticket types, so different types of tickets. And you can see that your parts, you can pretty much, find out a lot of information by just looking at this picture. Okay, you can see that the most tickets sold were upper level. Okay, we have some lower level, we have some floor tickets, we have some club tickets, and some platinum tickets. So the problem says there are 5,000 tickets available for a concert. The percent of available tickets belonging to each ticket type is shown in the graph. They want us to calculate the number of tickets available for each type of ticket. So we are looking to calculate the number of tickets available for each type of ticket. Well, in step 1, they want us to write a ratio to represent each type of ticket first. So the floor is at 16%. A percent to a ratio would just be, that would be 16 out of 100. Platinum is at 2%, which would be 2 out of 100. Club is at 8%, which would be 8 out of 100. Lower level is at 30%, which would be 30 out of 100. And upper level was at 44%, which would be 44 out of 100. Well, now that we have our ratios, we could set up and solve a proportion to find the number of each type of ticket. Well, if it's 16 out of 100 for the floor, well, if 5,000 are available, we need to find out, well, then how many out of 5,000? Well, what did I do to 100 to get 5,000? I multiplied by 50. That's what I'm going to have to do to my top number. And 16 times 5 is 80. Add that 0. That means X would be 800 floor tickets available. For platinum, that's 2 out of 100. What did I do to 100 to get 5,000? Again, you're multiplied by 50. So 2 times 50. Well, obviously, X is going to equal 100 tickets available for platinum. For the club, we had 8 out of 100. So we're going to have to set it equal to, well, then how many out of 5,000? Again, I'm going to have to multiply times 50 times 50. Well, 8 times 5 is 40. Add that 0. So X is going to equal 400 tickets available for the club tickets. Lower level was 30 out of 100. Well, so how many out of 5,000 times 50 times 50? 3 times 5 is 15. Add 2 zeros. So that means 1,500 tickets available in the lower level. And upper level, 44 out of 100. So how many out of 5,000 times 50? Times 50, that is going to be 2,200. I should have put an X there. So X would equal 2,200 tickets available for the upper level. So that had the most ticket types there. Okay, in the your turn, you're using the same circle graph and the same information to answer the your turn. It says, what percent of sold tickets not on the floor were platinum? What percent of sold tickets not on the floor were platinum tickets? And they want you to round to the nearest percent, which is the nearest whole number. So pause your video and try that. Okay, so since we're talking about the percent of sold tickets not on the floor that were platinum, you're talking about the ones not on the floor out of 5,000. So if 800 are on the floor, then how many are not on the floor? The first thing I'm going to do is subtract 5,800, or 800 from 5,000, which would give me 4,200 tickets that are not on the floor. Well, how many of those, what percent of those that are not on the floor were platinum? So out of 5,000 tickets, 2 out of every 100, 2% of the 5,000 ended up being 100 tickets. So not on the floor means if I take the, let's see, 100 minus the 5,000, that would be 4,000. So I could set up a proportion and say what percentage, what's the percent out of 100 if my total this time not on the floor is going to be 4,200, and I could, I'm going to have to leave this at, okay, I'm going to leave this at 100 because, let's see, if I subtract 2 from 198, that's so close. So let's just leave it at 100, and we're going to work this way backward to do this shortcut. 4,200, how did I get from 4,200 to 100? Well, I would have to end up dividing by 42. So that's what I'm going to do to 100. I'm going to divide by 42 to get my x. So 100 divided by 42, well, you know it's going to go twice, which is 84. When I subtract, I'm going to get 16. If I add a decimal and add a 0, 42 into 160, that would go 3 times. 126. You could keep on dividing, but since it asked us to round to the nearest percent, we're going to go ahead and stop there because that would still be right at 2%. So if you had any questions or yeah, this one was kind of confusing. We'll go over this again. But anyways, bar graphs, circle graphs is what we are talking about tomorrow in class. So anything you wanted to ask, jot your questions down and we'll talk about it tomorrow.